Okay, so I thought what might make most sense is to look at some of the things that we've been doing on moles. So first of all, what is a mole? Well, a mole is just nothing more than a certain number of atoms or molecules. So a mole of carbon would be a certain number of carbon atoms, and that number is called Avogadro's number, and it's 6 times 10 to the power of 23 atoms. I'm just going to just double check that number to make sure I got it. Yeah, so 6 times 10 to the power 23 atoms. So a mole of carbon would be 6 times 10 to the power 23 carbon atoms. Now, if I did a mole of water, it'd be 6 times 10 to the power 23 water molecules. So um, now, where it gets a bit confusing, so nobody would, if if we if I said, okay, so a water molecule is made out of H2O, so it's got two hydrogens and one oxygen, so it's obviously going to have 6 times 10 to the power 23 oxygen atoms, and 12 times 10 to the power times 10 to the power 23 hydrogen atoms, because you can see each one's got two, so it's going to be twice as many. And when we often get confused is when I say how many atoms in a mole of just oxygen. Now, oxygen is also a molecule. It goes around as molecules, and so we don't count the number of oxygen atoms. We double that because oxygen is also a molecule, just like this compound water. It's when we look at an element that happens to be in a molecular form, or we call a diatomic molecule, so a molecule with two atoms in it. We tend to forget to double it, and it can cause a bit of confusion. But it is really we're doubling a mole of oxygen atoms is 16 grams. Therefore, a mole of oxygen molecules is going to be 32 grams. So we double it for just the same reason we would double. We would double the hydrogen in water. That's just how many how many. Yeah, it's because that's each oxygen molecule, there are two oxygen atoms. Now, studying this a little bit more, what is so special about this number 6 times 10 to the power 23? Well, it just so happens that number, when I use that number of atoms, then I end up getting the mass ends up being the same as the mass number. So oxygen has got the mass number of 16. And so, well, it's probably just to reduce confusion, let's look at the ones that don't form molecules. So carbon has got a mass number of 12, or the standard carbon has anyway, the most common carbon. And if I have 6 times 10 to the 23 carbon atoms, it just so happens to end up equaling, so a mole of this just happens to equal 12 grams. So, well, why is that? Well, if we ignore the electrons, because the electrons are so light in comparison with the rest of the atom, it's made out of six protons. Each atom is made out of six protons and six neutrons. If we compare that with like hydrogen, well, okay, maybe not. Hydrogen's again a molecule, so maybe don't do that one. But by thinking about this a little bit more carefully, we realise that a mole of protons would weigh 1 gram, and what a mole of neutrons would weigh 1 gram, and so they've chosen this number so as a mole of protons or a mole of neutrons would weigh 1 gram, and therefore the mass number is always going to be the number of protons plus neutrons, and so it's going to end up being when you do that many of the atoms or molecules, you're going to end up as the mass getting the mass number. So that's what a mole is, and that's what's so important about that particular number. You could probably do a little bit of math to see if you can identify, therefore, what is the mass of one proton roughly, and what is the mass of one neutron. But we won't do that now, so I'll stop that video there. Yeah.